Welcome to the DIY Honda Garage channel. Welcome to the troubleshooting guide for DTC P0341, which indicates that there is an incorrect phase detected between the camshaft position, CMP, sensor A, and the crankshaft position, CKP, sensor. This issue can trigger poor engine performance or increase fuel consumption due to improper timing of the engine's timing components. Among the components involved, the CMP sensor monitors the position of the camshaft, while the CKP sensor monitors crankshaft position. The location of these sensors in the Honda Civic is critical. The CMP sensor is generally found on the cylinder head or valve cover, while the CKP sensor is placed near the crankshaft. Understanding this DTC and its related systems is essential for any technician aiming to resolve engine timing discrepancies efficiently. It sets the foundation for effective troubleshooting of this issue, ensuring the vehicle performs optimally. The error P0341 is directly related to the operation of the CMP and CKP sensors in the Honda Civic. The CMP sensor's role is to provide the engine control module, ECM, with real-time data on the camshaft's position, while the CKP sensor performs a similar function for the crankshaft. Proper coordination between these sensors ensures that the engine runs with the correct timing, which is crucial for performance, fuel efficiency, and emissions control. Specifically, the CMP sensor is typically located on the cylinder head or valve cover, while the CKP sensor is positioned near the crankshaft. The misalignment or malfunction of these sensors can lead to engine hesitation, decreased power, or even stalling due to incorrect timing signals being sent to the ECM. Several possible causes can trigger the DTC P0341 in the Honda Civic. Firstly, a faulty CMP sensor can fail to provide accurate camshaft positioning data to the ECM, leading to timing issues. Similarly, a malfunctioning CKP sensor can also compromise the engine's timing signals. Additionally, damaged wiring or poor connections between the sensors and the ECM can result in intermittent signals, contributing to phase detection errors. Environmental factors like wear and tear or exposure to heat can affect these sensors and their connections, ultimately impacting engine performance. Therefore, it's critical to systematically diagnose all possible causes before concluding the root issue. When dealing with DTC P0341, several symptoms may manifest in the Honda Civic, which often indicate an underlying problem with the engine's timing system. One common symptom is engine hesitation or stalling, particularly during acceleration, as the engine struggles to maintain the correct timing. In addition, there may be noticeable poor acceleration when the vehicle is under load, which can make driving conditions frustrating. Furthermore, you may notice decreased fuel efficiency as the engine's operation becomes inefficient due to incorrect timing perceptions provided by faulty sensors. If you observe these symptoms, it's essential to conduct a thorough diagnostic to ensure timely repairs and optimal vehicle performance. The initial step in troubleshooting DTC P0341 involves preparing the vehicle and its diagnostic tools. Start by turning the ignition switch to the on-to position, ensuring that the dashboard lights up without starting the engine. Subsequently, clear the diagnostic trouble code using the Honda Diagnostic System, HDS, to reset the system and check for any immediate issues. After clearing the DTC, take the vehicle for a test drive, maintaining a steady speed between 19 and 38 miles per hour, 30 to 60 kilometers per hour, for approximately 10 minutes, as this allows the engine management system to identify any existing problems accurately. After the drive, return to the diagnostic tool to check for any pending or confirmed DTCs. If DTC P0341 reappears, proceed to the next troubleshooting step. The second troubleshooting step requires a thorough examination of the variable timing control (VTC) system using the HDS. Perform the VTC test found in the inspection menu of the HDS, which assesses the operational efficiency of the VTC system. It's vital to interpret the results correctly. If the result indicates OK, proceed to the next step for further diagnosis. On the other hand, if the result is no, it may indicate a malfunction within the VTC system, thus warranting further investigation. This structured approach ensures that the VTC system's functionality is adequately verified before moving on to the next steps in the troubleshooting process. Continuing with the troubleshooting process, the next step involves checking the VTC status with the HDS. This action entails another test drive within the same speed parameters of 19 to 38 miles per hour, 30 to 60 kilometers per hour, for 10 minutes, ensuring that the engine operates seamlessly during this period. After the drive, access the data list on the HDS to check the VTC status. For accurate diagnostics, it's critical that the VTC status indicates on. This means the system is functioning as intended. Should the status not show on, repeat the test drive to rule out minor glitches. This careful monitoring of the VTC status helps in narrowing down the source of malfunction during the troubleshooting. As part of this systematic troubleshooting, Step 4 involves monitoring the OBD status for any indication of DTC P0341 through the HDS. Using the DTCs menu in the diagnostic tool, check if the screen indicates failed. If it does, it may pinpoint specific issues that require immediate attention. Conversely, if the screen reads passed, this could indicate that the system is operating normally at that moment, though it can also suggest that the issue could be intermittent. Should the screen show not completed, returning to Step 3 to recheck would be necessary. Proper interpretation of the OBD status is crucial for accurately diagnosing the engine's issues related to the timing sensors. In Step 5, we focus on the VTC oil control valve's operation, which plays a vital role in managing the engine's valve timing. This step involves testing the VTC oil control solenoid valve to verify if it functions correctly. If the solenoid valve is confirmed to be operational, proceed to the next step. However, if the valve is found to be defective or malfunctioning, replacement is necessary to restore proper functioning. The VTC oil control solenoid valve is crucial for maintaining optimal engine efficiency, and its failure can lead to significant impairments in engine performance. Ensuring its integrity at this stage is critical for the subsequent processes in troubleshooting DTC P0341. Next, in Step 6, we check the camshaft timing, a critical aspect of the engine's operation that ensures valves open and close at the correct intervals during the engine cycle. Accurate camshaft timing is paramount for effective engine performance and efficiency, so any misalignment can lead to poor operation or even damage. After reviewing the timing, if the camshaft timing is confirmed to be accurate, proceed to the next troubleshooting step. However, if there is any deviation identified, a reset of the camshaft timing is essential to correct the issue. This resetting process must be conducted following the manufacturer's specifications to ensure optimal performance afterward. Step 7 involves inspecting the cam chain to check for any signs of damage or stretch. The cam chain is responsible for synchronizing the rotation of the camshaft with that of the crankshaft, maintaining the correct timing for efficient operation. Over time, wear and tear can cause the cam chain to stretch or even to show visible signs of damage, which can lead to incorrect timing readings and subsequent diagnostic trouble codes like P0341. If any damage or noticeable stretch is identified, it's crucial to replace the cam chain as well as the auto tensioner to ensure that the timing remains accurate. This step is vital, not only for resolving the current issue, but also for preventing future problems related to engine timing. In Step 8, the focus is on inspecting the variable timing control actuator, which manages the adjustment of the engine's valve timing. This actuator is essential for the efficient functioning of the variable valve timing (VVT) system, allowing for variable performance based on engine demands. During inspection, if the actuator is found to be in good condition, you can then proceed to the next troubleshooting step. However, if there are any signs that it is faulty or not performing as it should, a replacement will be necessary. Ensuring the proper functionality of the VTC actuator is critical, as its malfunction can contribute to erroneous timing signals and trigger DTC P0341. For the final troubleshooting step, we will be focusing on resetting the engine control module, ECM, with the HDS to ensure that it is functioning correctly with the latest data. Begin by turning the ignition switch to the on position and resetting the ECM. Following this, perform the ECM idle learn procedure, which allows the engine management system to adapt to new sensor inputs accurately. Next, conduct the CKP pattern clear and CKP pattern learn procedure, both of which are vital for synchronizing the crankshaft position timing. Finally, take the vehicle for another test drive, maintaining a steady speed between 19 and 38 miles per hour, 30 to 60 kilometers per hour, for 10 minutes. After the drive, use the HDS to check for any pending or confirmed DTCs. If the DTC P0341 is still indicated, it's crucial to check for poor connections or loose terminals at the VTC oil control solenoid valve and ECM before repeating the entire troubleshooting process. After performing the necessary repairs related to DTC P0341, it's imperative to conduct a final verification to ensure that the issue has been effectively resolved. Begin by turning the ignition switch to the on position with the engine off. Reset the ECM using the HDS, allowing it to clear any previous DTCs. Following the reset, proceed with the ECM idle learn procedure, which adapts the engine controls to the current state of the vehicle. It is crucial to also perform the CKP pattern clear and learn procedure for proper synchronization. Finally, take the vehicle for another test drive, again at a steady speed between 19 and 38 miles per hour, 30 to 60 kilometers per hour, for 10 minutes. After the drive, check for any indications of DTCs with the HDS. If no pending or confirmed DTCs are present, the troubleshooting process can be considered complete. To prevent issues related to DTC P0341, proactive maintenance is essential. Regularly inspecting and maintaining the CMP and CKP sensors can significantly reduce the likelihood of malfunction due to wear. Additionally, it's crucial to keep wiring connections clean and free from corrosion, as poor connectivity can lead to intermittent failures and erroneous DTCs. Regular servicing of the variable timing control (VTC) system, including periodic inspections of the oil control valve and actuator, can ensure that these components function optimally. Following the manufacturer's recommended service intervals is essential. By committing to preventive maintenance, you can enhance vehicle performance and longevity, while reducing the chances of encountering timing-related trouble codes like P0341. In conclusion, DTC P0341 represents a critical timing issue involving the camshaft position and crankshaft position sensors in the Honda Civic from 2011 to 2015. Understanding the roles of the CMP and CKP sensors, as well as the VTC system, is vital for effective troubleshooting. Following a systematic troubleshooting approach ensures that you can pinpoint the exact source of the issue, whether it be sensor malfunction, wiring issues, or timing problems. By executing the required tests and following up with preventive maintenance practices, you can keep your vehicle running smoothly without recurring DTCs. Properly addressing DTC P0341 not only maintains engine performance, but also significantly enhances overall vehicle reliability. Please like and subscribe to the channel. See you next time.